In this video, I will talk about measures of variation. We will discuss how to find the range of a data set, how to find the variance and standard deviation of a population and of a sample, and how to use the empirical rule and Chebyshev's theorem to interpret standard deviation. So first, let's discuss the range. The range is the difference between the maximum and minimum data entries in the set. The data must be quantitative. So once again, this is the formula, the maximum data entry minus the minimum data entry. Here's an example. Two corporations each hired 10 graduates. The starting salaries for each graduate are shown below. We're going to find the range of the starting salaries for Corporation A. So the first one is Corporation A. This is in thousands of dollars. So when you want to find the range, it's best to put them in numerical order from smallest to largest. The minimum value is 37, the maximum value is 47. So you're going to take 37 and subtract it from the 47 and you get 10. So the range of starting salaries for Corporation A is 10 or $10,000. You can also do these calculations in StatCrunch as well as Excel. So I'll go ahead and show you how to do it in StatCrunch. I have the salaries listed in this column here, it says salaries. You're going to go to Stat, Summary Stat, Columns. You're going to pick the column that you want, and in this case we want salaries. And in the box where it says statistic, we want range. So we click on that, it'll show up over here in the right box. You hit compute, and as you can see, we get the answer of 10. I also have an Excel template that will do the same thing. So all you have to do is type your data values in column A. Once you have all of your data values in, the boxes in the yellow will come up. The answers will populate. The first one is the range. As you can see, it's 10. If you click on it, if you look up at this box up here, it'll tell you the Excel command that I used to get that number. Variation is the next thing that we'll discuss. If you go back to the two data sets that I did for Corporation A and Corporation B, both data sets have the same mean of 41.1 or 41,500. They have the same median of 41 or 41,000, and they have the same mode of 41 or 41,000. But the two data sets differ significantly. The difference is that the entries in the second set have a greater variation. So if you look at this histogram, these histograms that I've drawn, Corporation A has less variation. They have, as you can see, they're more centered about the mean. They have less variation, whereas in Corporation B, the data values are more spread out. Okay. So now we're going to talk about how to calculate variation, the variance, and as well as the standard deviation. I'm going to show you how to calculate population and sample. So in the real world, you usually don't have population data, depending on what it is. So we usually deal with samples. But I'll show you how to calculate the population's variance and standard deviation. So the difference between the data entry X and the mean of the data set is what you call deviation. So it's X, which is your data value, minus the mean. This is the formula for population, variance, and standard deviation. So in order to calculate the variance, you're going to subtract the mean from each one of your data values. You're going to square the answer. You're going to add them all up and divide by the total number of data values that you have, which is n. To calculate the population standard deviation, you're just going to take the square root of your variance. So this is really a nuisance to do by hand. That's why we pretty much have technology to do it for you, because if you make one little mistake, If it's a negative sign that you leave out or whatever, one little mistake can mess up the final answer. And if you have a lot of data values, you do not want to do it by hand. So the standard deviation measures the variation of the data set about the mean and has the same units of measure as the data set. The standard deviation is always greater than or equal to 0. When your standard deviation is equal to 0, that means the data set has no variation and all of the entries have the same value. As the entries get farther from the mean, that is more spread out, the value of the standard deviation increases. So these are the steps to finding the population variance and standard deviation. So the first thing you're going to do is calculate the mean. Next, you're going to subtract the mean from each one of your data values. After that, you're going to square each one of those answers, and then you're going to add all those up. Then you're going to divide by n. That will give you your population variance. When you take the square root, that will give you your population standard deviation. So we're going to go back to the data values for Corporation A, and I'll put those up in a minute. But the first thing I had to do was calculate the mean. The mean here is 41.5. So I'm showing you these steps on how you would do it by hand so you can have a visual of how this works. So I have my data values in the first column. In the second column, I'm going to subtract the mean of 41.5 from each one of those data values. So as you can see, I get negative answers and I also have positive answers. The next thing you want to do is you want to square each one of those numbers. So all of those numbers become positive. So you're going to square the negatives, that becomes a positive. You square the positive, that stays a positive. Then you're going to add this column up. When you add this column up, you get 88.5. Now that you've added them, you want to divide by the total number of data values. In this case, is 10. So your population variance, it will be 88.5 divided by 10, which is approximately 8.9. To get the population standard deviation, I'm going to take the square root of 8.9, and it's approximately 3. So the population variance is about 8.9, and the population standard deviation is about 3 or 3,000. Because remember, this was in thousands of dollars. The sample variance and the sample standard deviation they have the same formula as it does for the population one, except instead of dividing by n, you're going to divide by n minus 1. Okay, so you go through the same steps, find the mean, subtract the mean from each data value, square your answers, add them all up, and divide by n minus 1. So let's look at this problem here. In a study of high school football players that suffered concussions, researchers placed the players in two groups. Players that recovered from their concussions in 14 days or less were placed in group 1. Those that took more than 14 days were placed in group 2. The recovery times and days for group 1 are listed below. Find the sample variance and standard deviation of the recovery times. So I'll show you again how to do this by hand. You subtract the mean from each data value. And then you're going to square. That's the last column. You're going to add them all up. You get 39. We had a total of 12 data values in here. So when we divide, we're going to divide by 12 minus 1, which is 11. So you get 39 over 11, which is approximately 3.5. To get the sample standard deviation, you are going to take the square root of your variance and you get 1.9. So this can also be done in StatCrunch as well as my Excel template. So let's go ahead and do it in StatCrunch. In the first column, I have the times and recovery times in days. So we're going to go to Stat, Summary Stat, Columns, and we want times. So you'll see variance and standard deviation here. Variance and standard deviation here is for the sample data. There's also another standard deviation and variance right here. It says unadjusted. This is for population standard deviation and variance. So we don't want the population. We did a sample. So we're going to click these two, variance and standard deviation. If you want to click both of them, you're going to click on one, hold the shift button, and then click on the next one, standard deviation. So it pops up in the box on the right. We hit compute, and as you can see, we get our answers. We get 3.54 for our variance. Standard deviation is 1.88. We rounded to 1.9. If you wanted to use my Excel template, once again, you're going to have to, and where for this one, you have to type it in. When you do your homework, remember you can send your data over to an Excel file and then copy that data and then place it into this column if you don't want to type it in. So when I do it, as you can see, I have a sample variance and a sample standard deviation pop up in the yellow. We get the same answers that we did when we did it in StatCrunch. We got 3.5 and 1.88. Once again, if you click on these columns or these cells, you'll see the command that I use to get those answers. So we're still in Module 1, and we have an Excel template for Module 1. So in the last section that we did, we looked at measures of central tendency. So this is also in this Excel template. So if you look at the bottom, I have tabs. I don't know if you can see my mouse, but I have a tab here that says averages, and I have a tab here that says dispersion. So depending on what you're working on in the homework, this is where you switch back and forth. Everything will be in this Excel template, but in different tabs. Huh? So the standard deviation is a measure of the typical amount an entry deviates from the mean. The more the entries are spread out, the greater the standard deviation. So if you look at this first graph, this has a mean of 5 and the standard deviation is 0. And the reason why it's 0, it looks like all the data entries are all the same. So all the data entries were 5. So it looks like it had eight people or whatever, eight data entries, and they were all equal to 5. So as you can see, there's no spread. Everything is in one spot. Whereas in the second graph, the mean is still 5, but we have different data values. So this has a spread here, and this sample standard deviation is 1.2. This one, last one, also has a mean of 5, as you can see, but the data is more spread out. The sample standard deviation is 3. So the next thing we're going to talk about is the empirical rule, which is the 68, 95, 99.7 rule. For data with a symmetric bell-shaped distribution, the standard deviation has the following characteristics. About 68% of your data lie within one standard deviation of the mean, 95% of the data lie within two standard deviations of the mean, and 99.7% of the data lie within three standard deviations of the mean. So this is a visual of what I'm speaking of. So the mean is always in the middle. You can go out one standard deviation and 68% will lie within this blue section. You can go out two standard deviations and 95% of your data will lie between this beige blue areas. So you have to add the blue and the gray all together. And then three standard deviations will be approximately your entire data set. It will go from the green, beige, blue on both sides. So that's three standard deviations. So in this example, a survey was conducted by the National Center for Health Statistics. The sample mean height of women in the United States ages 20 to 29 was 64.2 inches with a sample standard deviation of 2.9 inches. We're going to estimate the percent of women whose heights are between 58.4 inches and 64.2 inches. Well, let's go ahead and calculate the standard deviations out. So if they told us that the mean was 64.2 and they told us that the standard deviation is 2.9. So if we were to go out one standard deviation, that means we take 64.2 minus 2.9, or we can take 64.2 and add 2.9. So that's one standard deviation. We're going one up and one down. So if you calculate it for one standard deviation, this will be 61.8. And when you add the standard deviation, this will be 67.1. Now let's go out two standard deviations. So what we're going to do is we're going to multiply the standard deviation by 2. And then we're going to add it and we're going to subtract it from 64.2. Okay, so when I do this, 64.2 minus 2 times 2.9, I get 58.4 here, and I get 70 here. If I go out 3 standard deviations, this time I am going to multiply the standard deviation by 3. And then I'm going to add and subtract it from the mean of 64.2. So when I do it, when I subtract it off, I get 55. And when I add it, I get 72.9. And I just want to make sure you guys know that this is 64.2. So let me go ahead and erase that and put that back in. 64.2. All right, so I have all my numbers, so I'm going to show you what it looks like on the graph. Okay, so if you look along the x-axis or horizontal axis down here, you see I have my mean in the middle. I went on one standard deviation. We said that's 61.3 and 67.1. This should be a 3 here. Sorry. This is 3. And 67.1, then we have 58.4 and 70, and then we have 55.5 to 72.9. So the question asks, estimate the percent of women whose height is between 58.4 and 64.2. So that's the blue shaded area. So you would take 34.13 and the 13.59 and you would add them up together and you will get 47.72%. So about 47.72% of women are between 58.4 and 64.2 inches tall. So I know you're asking, where did I get the 34.13 and the 13.59? I got it from this graph here, because when you split it up into those sections, those are the percentages. The last thing I'll talk about is the Chebyshev theorem. The portion of any data set lying within k standard deviations, where k is greater than 1, of the mean is at least 1 minus 1 over k squared. So if k is equal to 2, that means 75% of the data lie within 2 standard deviations of the mean. If k is equal to 3, then that means 88.9% of your data lie within 3 standard deviations of the mean. So in this example, the age distributions for Georgia and Iowa are shown in the histograms. We're going to apply Chebyshev's theorem to the data for Georgia using k is equal to 2. What can you conclude? Is an age of 100 unusual for a Georgia resident? And explain. So k equal to 2 means k standard deviations. So if I multiply my standard deviation by 2, since we're going out 2 standard deviations, and we add and subtract from the mean, I get negative 70.3 and I get 81.9. So those values are 2 standard deviations away from the mean. Since age cannot be negative, we're just going to change negative 7.3 to 0. So we can say that at least 75% of the population of Georgia is between 0 and 81.9 years old. So an age of 100, it does not lie within those 2 standard deviations. It will be further out. So that would be unusual, because most of your data set should fall between 2 standard deviations, and 100 is further away from those 2 standard deviations. This last example says, from a sample of n is equal to 108, the mean number of televisions per household is 5, with a standard deviation of 1 television. Using Chebyshev's theorem, determine at least how many of the households have between 2 and 8 TVs. So they told you that the mean is 5 and we're going out 1 standard deviation. So it looks like it's going from 8 and then down to 2. So it looks like it's going 3 up because that's how they got the 8, and it looks like it's going 3 down as that's how they got the 2. So this looks like it's 3 standard deviations. So based on Chebyshev's rule, when k is 3, 88.9% of your data lie within 3 standard deviations. So we know that 88.9 of these people will have TVs, but the question is how many of these households? So we know we took a sample of 108. So I'm going to take 0.889, I'm going to multiply by 108. When I multiply it out, I get 96. Okay? So at least 96 out of those 108 households have between 2 and 8 TVs. That's the end of this lecture.